All right, 6.1, number 16. We were given the graph of the sine of 2x and the sine of x, and we were asked to find the shaded region of the area between these two curves. So what we have to notice is that we have two different sections, meaning there's going to be two different integrals. And those integrals are going to have the bounds from here 0 to some point where the top function changes. So at first the sine of 2x is on top, and then the sine of x switches to be the top function here. So drawing our rectangles, or approximating rectangles, we see that the width of these rectangles is going to be small portions of the x-axis. That means we're going to integrate with respect to x. Okay, so both of these are delta x. The height is going to be the top function minus the bottom function. And then the interval is going to go from 0 to wherever this point of intersection is, all the way to pi, the end of the given interval. Okay, so in order to find this point of intersection, what we need to do is we need to set these two functions equal to each other. We have the sine of 2x is equal to the sine of x. Now, algebraically speaking, I don't really know how to solve this unless I switch the sine of 2x using one of those double angle theorems or identities. And you can look in the front of your calculus book or the back of your calculus book, depending on which one you have, for those identities. And so I looked it up, and the sine of 2x is 2 sine x times the cosine of x. And that's going to equal to the sine of x. And to solve something like this, we set it equal to 0. 2 sine of x times the cosine of x minus the sine of x equals 0. We factor out a sine, so we have the sine of x, and what's left is a 2 cosine, so 2 cosine of x minus 1. Okay, and all this is equal to 0. And we do this because now we have a product, so either this term is 0, so 0 times anything is 0, or this term is 0, 0 times whatever is equal to 0. So we know that the sine of x, using the unit circle, the unit circle, the y-coordinate corresponds to the sine function. So the sine of 0 is 0, and the sine of pi is 0. So we get x equals 0 or pi. And notice that's the beginning of our entire interval and the end of our entire interval. Now we just need to find this one. And that occurs when 2 cosine of x minus 1 is equal to 0, or 2 cosine of x is equal to 1. Divide by 2, the cosine of x is equal to 1/2. On the unit circle, we have some special points. We have the point here at pi over 3, where we have square root of 3 over 2, comma 1/2. And then we have this pi over 4, which is the square root of 2 over 2, comma the square root of 2 over 2. And then right here, we have pi over 3, which is 1/2, comma the square root of 3 over 2. I don't know if you can see that. Let's see, I wrote it kind of small. But pi over 3, for cosine, the x-coordinate corresponds to the cosine function. So at the cosine of pi over 3, we have that cosine equaling 1/2. So we have the cosine of pi over 3 is that third intersection point, or rather the second intersection point that we were looking for. So to set up this integral now, we're going to integrate from 0 to pi over 3 of the sine of 2x, because that's our top function, minus the sine of x. Okay, and this is going to give us the height of our approximating rectangle. Okay, and then this is the width is dx. Okay, so then we add that to the integral from pi over 3 to pi, where this time the sine of x is the top function. Kind of running into that, so I'm going to kind of curve down here. Minus the sine of 2x dx. Okay. Now, the sine of 2x, we can do a little u substitution over here. We can say u is equal to 2x, du is equal to 2 dx, or 1/2 du is equal to dx. So we'd also have new bounds. U of 0 is equal to 2 times 0, so that's 0. U of pi over 3 is equal to 2 times pi over 3, so that's 2 pi over 3. And then we're also going to have this pi for over there, so u of pi is going to equal 2 pi. So now we can split these up into 4 different integrals. We're going to integrate for this one. We have the 1/2 from 0 to 2 pi over 3 of the sine of u du, minus the integral from 0 to pi over 3. We didn't have to change or do any u substitution here. Sine of x dx. Then we're going to add on this difference over here. So the integral from pi over 3 to pi, we didn't make any substitutions on this one. Dx minus the integral from, let's see, we had 2 pi over 3 to 2 pi. So this is 2 pi over 3 to 2 pi of the sine of u du. Okay? So now this one here, the antiderivative of sine, is the negative cosine. We have the 1/2 from outside, so we have negative cosine of u evaluated from 0 to 2 pi minus the negative cosine of x evaluated from 0 to pi over 3. Excuse me, this wasn't 0 to 2 pi, it was 0 to 2 pi over 3. Okay. Plus the negative cosine of x evaluated from pi over 3 to pi minus the negative cosine of u evaluated from 2 pi over 3 to 2 pi. Okay? So now the cosine of 2 pi over 3, looking at a unit circle again, right here, if this is pi over 3, this is 2 pi over 3. And remember that gave us the 1/2, so this is going to be a negative 1/2. So we have a negative 1/2 times a negative 1/2 minus the cosine of 0 is 1, so minus 1, and then let's see, then we have plus the cosine of pi over 3, remember, was 1/2, so 1/2 minus the cosine of 0, which is 1. So we have plus a minus, so minus the cosine of pi is actually right here at negative 1. So we have negative 1 minus the cosine of pi over 3, which was 1/2. And minus a minus, so plus the cosine of 2 pi is just 1. And you know, with this one, this u, I dropped a 1/2, so there should be a 1/2 here, and a 1/2 here, and a 1/2 half here. So this is the cosine of 2 pi, which is 1, minus the cosine of 2 pi over 3, which was our negative 1/2. Okay, so now we have a negative 1/2 minus 1, so that's 3/2, and it's negative 3/2 times 1/2, so a negative 3/4. So a negative 3/2 times a negative 1/2 is a positive 3/2, plus 1/2 minus 1, which is a negative 1/2 or a negative 2/4, keeping the same denominators. This is another negative 3/2, so minus a minus 3/2 is plus 3/2 or 6/4. And then this one is 1/2 times, let's see, this is 1/2 minus a minus, so plus 3, so 1 plus 1/2 is 3/2 times 1/2 is another 3/4. So now we have 3 minus 2 is 1, 7, 8, 9, 10/4. And, or that's 5/2. All right, 5/2. I should probably check that in the back. But, yeah, so as long as my algebra was correct, that's how we do it.